and definitions, right? So those are the reasons why. We say something, and then we do it. In this section, we introduce properties, right? The addition and subtraction properties. Multiplication, divisions, distribution. We really said that substitution could be used in a lot of cases, but we want to be as specific as we possibly could. And then we also introduced or talked a little bit about reflexive, symmetric, and transitive properties. Okay? So when we do these kind of problems again, that's the thing that we're going to look at. We're going to try to do that process every time as much as we possibly can. And that's what's going to hopefully help us do a good proof. So, if I was asked to do this as my first algebraic proof, how am I going to start? Before that, what's the first step again? Write down the problem. So, this is the given. Okay? This is the given. That would be my first thing. I'd have to write down that whole problem, and I would write given down, right? Then what did you say? What's your next step? The distributive property, right? So if you happen to say multiplication, totally fine. No big deal with that. But you really should say distributive property. So not only are we going to do the problem, but we're going to name it. So what do we get if I distribute? What do you get? Say it out loud. All right.
Oh, 10, you get 6a.
Minus 6a?
Yep. And then negative 4a, negative 28.
Perfect. So that's my distributive property, right? All I did was actually multiply. Next step, what would we do? Combine like terms, exactly right. So we would combine the numbers, right? 10 minus 28 and negative 6a minus 4a. So what would you call that? What is the reason that I am capable of doing that step? Okay, yeah, Pembus. Okay, I can live with that. But what did you actually do in the problem? Subtracted? Maybe you can say addition, because in a sense we kind of added. Here's where, again, they just simply say substitution. But I would much rather you say subtraction. And notice here, in some cases, the book will do this in 2 steps. Some cases, like here, they did it all at one time. So in some cases, they might do combine like terms, like Horace said, with the numbers as one step, and then do the variables as the next step. But in this case, they did the whole thing. So as Ms. Hines said, I'm using PEMDAS. What's my next step in PEMDAS? In this case. How do I get that A all by itself? Add what? Add 18 to both sides. Perfect. Now they actually show it. You don't actually have to show that step if you don't want to, but you just know that that's what you're doing. And then we would do what? So here's kind of a picky step. I wouldn't include this step. If I do the addition, I'm going to just show this as my next answer. I'm not going to say that I'm going to substitute my answer in for it. Okay? Last but not least, what would I do? Divide by negative 10. Exactly right. And so again, then they come down. So when you said that you did division, I'm going to just say I'm done with the problem. I'm not going to say I'm going to substitute the actual answer into that problem. But if you want to do that, that's totally fine. But that's where the number of problem or the number of steps in the actual proof might vary a little bit. So my answer is negative 1. Do you want to go through another one of those kind? So basically, again, all I'm doing is the steps. Exactly what I'm doing in the problem, right? So again, the first step here is me writing out the given. Then I would distribute. Then I would combine them like terms. So this problem right here is exactly like the last one. And again, this is what I'm talking about when you start doing these on your own. If we give you an odd and an even one back to back, they're probably pretty much the exact same problem. use that odd one to kind of get the method, and then try the even one on your own. Okay? Don't just look in the back of the book and copy it down for the odd one. All right, so now they actually want you to try to figure this out on your own. Okay? So if the distance d an object travels is given by d equals 20t plus 5, the time t that that object travels is given by t equals d minus 5 over 20. Write a two-column proof to verify this conjecture. Okay, so basically what they're saying is this. In this problem right here, they're saying this right here is the given, and this right here is my proof. Okay, so this is what's given at the top. The box is what they want you to prove by the end of the problem. Does that make sense? And that's what they'll give you every single time in your proofs from here on out. They'll give you a given and they'll give you a proof. The proof is the answer, remember? That's my last step. When I get to that, I know that I'm done. So, what's my first step in a two-column proof again? Come on, wake up. Write the given, right? And why can I say that? Because it's given. So, there it is. My reason why. So, this is basically what they will actually give you on the quiz, on the test. All right? So, there it is, given. So, in a sense, we want to solve for t. Okay, so again, you need to go back and look at that proof statement. The proof statement is what you are shooting for, in a sense. Right? So, remember, the t is what we're trying to get all by itself. So, what would I do? What's the first step in solving for t?
Subtract 5.
Subtract 5 from both sides. And why can I do that? Because you subtract it, right? So, d minus 5, they call it the addition property of quality. If you use subtraction, I'm totally game with subtraction. What's my next step? Divide by 20, right? So I'm the division property. Now here's the tricky part. This is kind of what our goal was, right? To get t all by itself. Well, what happened in the original proof? When they gave me the original proof on the last page, it was the other way, right? The t is on the left-hand side. So, how do we get from where we're at to the t on the other side with one of those properties from the other day that I told you that might be a kind of a weird one? Boom. Did you cheat with that, or did you just come up with that?
Well, I did not come up with that. I have
So, remember, anytime that you flip-flop things, but you keep them the exact same, you get the symmetric property. Okay? Now am I done? How do I know I'm done?
It's the same as what.
Because I'm at the proof, right? Exactly right. Once I get to the proof, I'm done. So, this problem right here would have been 4 steps. So we would have said number 26 is worth 4 points. That's what we would have done right there. Not too bad, right? Any questions with that one? So, if the formula for finding the area of a trapezoid is 1/2 b1 plus b2 times h, how can I get h to be all by itself? That's basically what it's saying, right? Okay. So, here's my given, here's my proof again. What's my first step? The given. Okay. What would be my first step in solving for h in this problem? This one's kind of confusing a little bit. But what's my first step in solving for h in this? Come on, algebra people. How can I get h all by itself? How do I get rid of 1/2 or b1 plus b2? Times by what? Times by 2 on both sides. Perfect. Now here's the question. Does everybody have to go in the order that Lauren does? Does everybody have to multiply by 2? Could you divide by B1 plus B2 first? Yes. So when you're doing proofs, and you go and start checking it with somebody else, and your steps don't exactly match up, but you do the exact same thing, just in a different order, is it wrong? Heck no. It's just a different way of doing the same proof. So you need all the steps, it just doesn't matter the order. So Lauren's right though, we're going to multiply both sides by 2, so we would have had 2a, and then b1 plus b2 in parentheses times h. So how do I get that b1 plus b2 to the other side? Divide, right? So let's see what they did. So they did it the exact same way that Lauren did it, right? They multiplied by 2 first, and then they divided by the b1 plus b2, and then the last step would be. So this right here would have been multiplying by 2, and it should be a. So again, you could have done it the other way, but this was one way of doing it. Okay? So those are algebraic. You're basically taking an algebra problem and just doing the problem. Hopefully those aren't too complicated. Now we start thinking actual geometric proofs, okay? If A is congruent to B and B is equal to 2m angle C and the measure of angle C is 45, then the measure of A equals 40 or 90. Write a 2-column proof to verify this conjecture. What the heck, right? Does that make sense to anybody? So let's try to explain this. In this problem right here, this right there is all my what? Given. The given. So the if part, which we called the what? The hypothesis. The hypothesis is always going to be my given. So what's my proof statement? M angle A equals 90. What does M angle A really mean? The measure of angle A, right? So the other way that they could have written that was saying angle A is equal to 90 degrees. And put the little degrees in. Okay? So, what do you think we're going to do? What's the first step that I would do in this problem? The given again, right? Again, if you forget that first step, you're in a lot of trouble. But there's my given, so they write it out. And we're going to start out by writing that first thing. Now again, notice, they took the whole given and wrote it as one step. Now you can split this up. Alright? Or you can just do it all at one time. If you split it up, it still only counts as one step. Now we start doing, and so here's the biggest question that's always asked me, especially at the beginning of these things. Where the heck do I start? How do I know what to do first? What's the first step? Okay? Now this is the hardest part to learn and get used to. So my recommendation is to always use something in the given. Okay? Use something in the given. So, what can I do here? Anybody have any idea what the first step is that you would try to do here from this? Remember, what's our goal? Our goal again is that we figure out that the measure of angle A is equal to 90. Okay? So, if this is all the things that are given, A and B are congruent to each other. Angle B is 2m, or 2 times whatever C is, but we know that C is equal to 45. So, where do you think we start? At 45. Okay? So, somebody wanted to start right here. That's totally fine. It's already given. They didn't do it that way. Okay. So if you did this with your 45, theirs is all the way down here. So again, notice the difference of this. Somebody said that about the 45 over here. I don't know who actually said it. You could have started right there. But again, remember when we're wanting to talk about numbers, that we should always turn it into equals instead of congruence. So that's why they showed this step right here. Taking this and turning it into actually numbers. So again, anytime that you have congruence, but you want to compare things using numbers, you need to do this step right here. And we kind of mentioned this the other day, but this is one step right here that's kind of hard to get into your melon. Okay, it really is. But anytime that you want to do equals, you need to do the definition of congruent angles, or the definition of congruent whatever you're talking about. Could be segments, could be whatever. Okay. So then, a couple things. You could have went to the 45, because we know that in here, basically what they're saying when they do the transitive property is that if A and B are equal to each other, and A is equal to 2MC, because they gave us that, the only reason that works is because my angle A's match up, and that's my transitive property. Right? Measure of angle B, measure of angle B, so we end up with A is equal to 2MC. And then we know that angle C is 45, so we can multiply that by 2, as I think Dave said earlier. And then if we get that, we get the measure of angle A is equal to 90 degrees. Well, what do we know about that? Why do we know that the measure of angle A is 90? Because all we did was multiply here. And then if some angle is equal to 90 degrees, what's true about it? They don't tell us. What's true about this right here? It's complementary, or it's a right angle, right? And then don't forget, the biggest thing here is that you have to realize, what is my proof? What are they asking me to find? And so anytime that I get to that proof statement, I know that I'm done. Now, again, see how they kind of did the, what I would call sandbagging way? They're putting substitution down a lot. Substitution is kind of a cop-out when they don't really know what the answer is. It's the easy way out, okay? So in this first one, I would have said we multiplied. And in this one, then I would have said, you could have said substitution, or you could have said like the definition of right angles or something. But I would be as specific as I possibly can. Okay? Now again, here's where it gets a little sketchy, because some of these problems are a little harder, but I want to show you one more. And the biggest thing here is, you're probably going, oh my God, I'm totally lost, I don't get any of this. What I want you to remember is that this is going to get way easier. And it's going to get way easier because we're going to do a lot of them. Okay? So, let's try this again. Justify the proof. If angle ABD and angle DBC are complementary, then angle ABC is a right angle. Okay, so again, what is my given? My given is the part that's the hypothesis. So my given is angle ABD and angle DBC are complementary. So the first thing in your mind is this. What the heck does that mean? What does it mean if things are complementary? They add up to 90 degrees, right? So somewhere along the line, I have to show that those two angles are equal to 90 degrees. What else did we say is going to be really helpful in this? Okay, the box will help us. Yeah, okay. What else? Along with your box, what else could I do? Draw a picture, right? So if I wanted to draw a picture of this right here, anybody have an idea of ABD and DBC are complementary? Maybe you don't. Maybe you don't get it. Adding up to 90 degrees is exactly right. We're set it over here. But do they have to necessarily be touching to be complementary? Right? Because I could have a 45-degree angle on this board, and I could have a 45-degree angle on this board, right? So they don't have to be touching. But are they in this case? Probably, right? So what does this lead you to? Sometimes, remember one of the things that we talked about that one day was to work backwards? You might go to the prove and read that prove statement first and draw the picture from the prove statement. So what picture would I draw? I would draw my right angle of ABC. And where would B be? In the vertex, right? And what kind of angle do I have? So what should I use, Ms. Hine?
Right angle.
Your box, okay? Now, where is ABD? Where's D?
It's like that you can make it bisect, like BB.
Everybody agree with that? Okay? So, do I have ABD now? And do I have DBC now? And are they complementary?
Yes.
Because I know that because of the box, right? All right, so we're ready to go. Here's my statement. ABD and DBC are complementary. Why can I say that? Because nope. Why can I say that first statement? Because it's given, right? Do not forget the given. I'm going to throw my marker at you, remember? The given's given for you. It's a cheap point. So this is my first step. Here's my next step that they came up with. The measure of ABD plus the measure of DBC equals 90. Why can I say that? Definition of complementary. Exactly right. So again, we're building off the things that we know. They told us that they're complementary. I automatically know if two things are complementary, they have to add up to 90 degrees. So my reason why right over here would have been the definition of complementary angles. Exactly right. Why can I then say the measure of ABD, so basically I'm saying the same exact thing, is now equal to the measure of ABC, which was 90 degrees. Why can I say that? Okay, maybe adjacent angles. What else? Why can I say that this 90 is ABC?
Right.
It's a right angle. Okay? But what did I do with my actual angle to the number? Or the number to the angle? They're representing the exact same thing, right? So I'm substituting it. Now this is a classic case of where you actually need to use substitution. Flushing. Okay? Instead of 90 playing in the game, we're bringing in the measure of angle ABC. They're substituting it in for 90. Okay? How do I know that the measure of ABC is equal to 90? Because of the box. And what's the box tell me? That it's a right angle. So my reason why for step D is the definition of a right angle. And then the last thing, ABC is a right angle. Again, I could use the definition again. Or this right here, I could use substitution 2 times in a row also. Because basically I'm substituting, maybe I use symmetric property here. Right? ABC is equal to 90. They're the same thing on both sides. Maybe I use, what happens if I have this part and this part in 2 different problems, and I would have rewritten them the other way? What would I have done to the measure of ABD plus the measure of DBC? I'd have pulled it out of there. So when we pull it out of there, what did we call that? Begins with the T. The transitive property, right? If A is equal to B and A is equal to C, if I take A out of both, then I get B is equal to C. And that's what we had here. So I would really say that this was probably transitive. And then this one down here is the definition of a right angle. So again, lots of different ways of getting from point A to point B. A lot. So again, when you help each other out, when you look in the back of the book might not be the same thing that you're thinking, which is probably a good thing. Okay? So don't get discouraged. We're going to really concentrate in this section about doing the algebraic proofs. If you can start getting that steps down, the rest of this will come and become easier and easier as we do it day after day. Okay? Trust me on it, it will. Right now, this is totally a new concept, and your mind's probably honestly blown. And I don't disagree with that. So you gotta just take it slow. And we still have about 15 minutes, so make sure you work in class in case you have any problems. And then make sure you take advantage of before school or after school, coming in to ask questions, and J's. Okay? So again, look, when we write down the assignment here, notice number 18 is worth 7 points, number 23 is worth 6 points, 24 is worth 6 points. I would guess these are all proofs. And that tells you how many steps there are in each of those proofs. Now again, don't freak out that there's that many points, because it could just be an algebra problem that you need to work through, especially today.